Hello class, we're on lesson 2 of chapter 5. We have a cartoon here and we're going to go ahead and read. We have one of the characters saying, I have a problem, I need $1. And this is Broomhilda, and Broomhilda responds, okay, here. Of course there's a sign back there, it says problem solved for $1. And now Broomhilda decides to charge. Well, wait, that'll be $1 please. Okay, here. Walks away, says, I have a problem, I need $1. And then I think we just discovered perpetual motion, meaning he's getting $1 and she's giving $1, but then she's charging $1 back, so never really solves this problem. Well, let's read on. In the first panel of this cartoon, Erwin is given $1, and in the second panel, he gives back the $1. Although it wasn't immediately apparent to him, it is easy to see that he is now back to where he started. Adding $1 followed by subtracting $1 is equivalent to no change. Because subtraction undoes addition, the two operations are called inverses of each other. We used the word inverse earlier to refer to a type of variation, but we're now using it in a different sense. So let's erase our brain right now. We really can't do that. There is a purpose in saying inverse in a certain manner and in another. So understand that we're just going to use this in a different way. And we have here, if one operation undoes the effect of another, the operations are inverses of each other. And they are called inverse operations. And you can see sort of a similarity, something going up, the other one's going down, okay? In this case, we have an inverse is something that's undoing something else, okay? So subtraction is the inverse of addition, because for any number y that we add to x and then subtract from the sum, the result is always the same number as which we started. So we have here an example. It kind of looks like it's just a simple equation. We have x plus y, and then we're just going to subtract y, and that's going to be equal to x, right? Of course, we know that. And addition is the inverse of subtraction, excuse me, because for any number y that we subtract from x and then add to the outcome, the result is always the same number with that which we started. So if we had subtraction x minus y, and we simply added y, we would then, the value would be equal to x, okay? So we can see what's going on here. This is offsetting. I think we use that word. Canceling out is another way. In this case, we use the word undoes. So we have a negative y and a positive y, as well as a positive y and a negative y. So let's read on. To see why this is so, remember that subtracting a number is equivalent to adding its opposite. Because of this, x minus y plus y is equal to x plus negative y plus positive y. All they're simply doing is changing here. We can look at these differently. We can say x plus y and change that to, instead of minus y, to plus negative y. And we could have said this the same here, x plus negative y plus positive y, right? And that's all we did was change the subtraction here to addition. And we can see that what we're left here really with the opposites, okay, the positive and negative, and the negative and a positive. So they offset each other, they cancel out, they undo each other, and basically what you're left with in both of these is x, okay? Now, the sum of the number and its opposite is 0. And so we can say negative y plus y is equal to 0, and x plus negative y plus y is equal to x plus 0. Okay, so we could simply substitute over here if we were writing these. Let's take this one at the top and just continue. We could have just simply expressed this as x plus 0, because regardless of what value we use for y, it will cross each other out. Remember, whatever value y is will have to be the same value here. So we put a y value. If it were 10, well, this would be negative 10. Okay, and it wouldn't be negative 9. It would have to be negative 10 because it's y, and y is equal to a particular number. So without even using numbers, we can just simply say that the variables themselves would cancel out, because whatever y is, its opposite would cancel out, offset, undo, and basically make it 0. So we can say x plus 0 is equal to x, and this is equivalent to that. Let's just finish reading the chapter here, or the lesson. Multiplication and division are also inverse operations. For example, if a number is multiplied by 3 and the result is then divided by 3, the answer is the original number. So in general, if a number x is multiplied by any number y other than 0, the result is then divided by y. Then we have, and then let's clear up our board here. Let me grab an eraser, and now let's see, I'm going to probably save this side here, and we can now discuss multiplication and division. And as we've spoken throughout the year, we know that that addition and subtraction are cousins, and they're siblings to each other, as well as division and multiplication. And in this case, we can see how inverse operations are used. Let's see, we have x, and we said that if we multiply it by y and then divide it by y, we would be left with x. And if a number is divided by any number y other than 0, the result then is multiplied by y. Then we can say now, in this case, we have x over y, right? We have x over y, and if we multiply that by y, then we'll be left with x. So this is, we're not really working with equations here as much as we're working with a method in which we can isolate, simplify. There's going to be a lot of application to this throughout the rest of your math life, and not just this chapter, not just this lesson. Most of these early lessons in algebra are giving you a foundation with which to work with. It's a toolkit. If you were to go to school for carpentry, and you're going to learn how to use all these different tools, drills and saws and hammers, and obviously you would not use a hammer to cut a piece of wood. It wouldn't necessarily be a nice clean cut if you tried. But so you have to know which tools to use, and we're building your toolkit so that later on, when you have a more complex problem, you can understand which method you can use to further simplify and solve your problem. So as you can see here, I just want to point out that we have what's very similar here, because if we were to simply say that x over y is equal to, x over y times y, I could also express that, could I not? Any number divided by 1 is itself, right? So I could say x over y times y over 1, right? And what I'm trying to show you is that these two are the same, okay? And if we were to just then do our multiplication, we follow our rules for fractions. We could multiply fractions by multiplying the numerator and denominator. We would end up with xy over y, right? Or x times y. So really these are the same. They're just expressed differently. And if you're not very strong with fractions, it's something that I suggest that you become stronger with, because that's really what you're going to be doing. A lot of fractional work, and I'm not talking about just numbers, but particularly with variables. And as you can see, this is a simplification. If you were to be given this and asked to simplify it, well, you say, well, this divided by this is equal to 1. Therefore, the answer is x. So it's a lot easier if you know how to use fractions, what you're allowed to do. I've been stressing that this is not equal to x plus y over y, okay? Which means you cannot just take y and cancel out, because these numbers are being added. This is a factor all on its own, so you couldn't just detach this y. But in this case, when you're multiplying, and we've given you many examples in the past, you can just simply cancel these out, because y divided by y is actually 1. And without going any further, and it will probably discuss that at length throughout the year, as to how numbers which are factors, in this case they're factors because they're being multiplied rather than terms, how these relate to the factors below. This is one factor all on its own. And well, like I said, we'll discuss that throughout the year. We do have an example here, and let's go ahead and follow the example. Let me clean up my board again so we can do our examples. And the first one they give us is, what operation on the expression x minus 3 would give x as a result? So what operation, what would you do? What would you multiply, divide, subtract, add? What could you do to x minus 3 so that this becomes x? Now we just learned that if we did the inverse operation here of minus 3 being plus 3, that would be the inverse. That would yield a 0 here. Okay, so the inverse or the inverse operation, or the operation that we could perform here to make this x, would simply be to add 3. Okay, I want to be very careful again, and I'm not trying to express this as an equation, though it can be written as an equation. This is more the result. So we're looking at the expression, and if we were to wind this back a little bit, we were simply given this expression. What could I do to this expression to make it x? Well, I would add 3, and that means the 3's would offset. Okay. Number 2 says, what operations on the expression 5x plus 1 would give x as a result? Okay, so this is a little more complicated, and that's a horrible 5, so let's try that again. And let's write 5x plus 1. Now, it looks like we'd have to do more than one thing here, because I see x surrounded by a lot of different things. The first thing that I would do is I would subtract 1. Okay, by subtracting 1, now I've isolated this to be 5x, right? Now what could I do to turn this into x? Well, I would divide this by 5, right? And we learned that this would be the y, so to speak, that we spoke of before. And if we divided this by 5, the answer would then be x. That would give us x. So this is just, again, how do we deal with terms? How can we deal with expressions? What can we do? Now we're going to learn further along that when you have an equation, there are certain rules, and if you follow them, you can do these things. If this were an equation, and this is what we're building towards, I don't want you to just simply think that we're able to just change an expression for no reason. There's a reason for this, because we're going to have one day, say, 5x plus 1, and that's going to be equal to 11. Now that's an equation, and now it's all tied together. Now I have to solve this for x. So by learning these things, by removing things over here, or adding things over here, or dividing over here, I will be able to solve this. And again, this is kind of a little bit of a sneak preview, but I wanted you to see the rhyme and reason to what we're doing. Well, what would I be allowed to do here? Well, I could subtract 1 from here, right? But then, remember, in an equation, whatever I do to one side, I need to do to the other side. I think we already discussed this to maybe a small point, but I'm allowed to do this because they would still be equal. If I subtract 1 from this side and I only subtract 1 from this side, then they would still be equal. Well, what do I get when I subtract 1 from each side? I would end up with 5x, and that's going to be equal to subtracting 1 from 11 would give me 10, right? So they're still equivalent. You might say it's changed, but it's still equal because we did the same. I think we use an example. If you have 4 candy bars and I have 4 candy bars, and I subtract 1 from you and subtract 1 from me, we would both have 3 candy bars. So we're allowed to do that. Okay, we were equal here and we're still equal here because we perform the same operation with the same value. So let's take a look. Now we're going to apply this this little tool that we learned here by dividing by 5. Now I can't just divide 1 by 5. One side I'd have to divide both sides by 5, right? I'm just putting that little equal sign to show you I'm doing the exact same thing to each side. Now what's 5x divided by 5? Well, we know that these would cancel out because 5 over 5 is really 1, and that gives me x. And now I simply divide 10 by 5 and I get 2. So that would have been our answer. X is equal to 2. So this is why we're learning these inverse operations. Very important. We're going to spend a lot of time in this chapter learning these things because they're critical, they're key. And if you don't feel comfortable with them, we're going to need to spend a little more time until you understand fully why you're doing this and how to do that. These are simple mathematical operations that can help us to solve problems. If we go back and put our x into our x value of 2 into the equation, what would we have? We'd have 5 times 2 plus 1 is equal to 11. And we know 5 times 2 is 10 plus 1 is 11, so 11 is equal to 11. So this is very important. This is critical. I really cannot emphasize the importance of learning this because this is going to be pretty much what you're going to do for the rest of your math lives in terms of simplifying solving problems. Okay? That's the end of this lesson.